Welcome to Gravitational Waves and How They Are Created. So, our journey begins about 100 or so years ago when Einstein developed the theory of general relativity, which is that space time is like a blanket where more massive objects create bigger dents and more curvature. And it's kind of hard to tell in that drawing, but in this one, here's a simpler side by side view where the reddish orange star represents a sun and the blue represents our Earth, showing the difference in curvature in space-time. And this little green dot represents a black hole where the mass is so large in such a small amount of space that it in turn creates an incredibly large, what would you call, divot in space-time. And now, so where do gravitational waves fit in all this space-time nonsense? Well, Einstein predicted that if we could have all these dents and curves in our space-time, that we could also have ripples that would ripple through all parts of space, as you see here, with the colorful planets and stars on the rippled line. Now, gravitational waves are only created in very, very extreme high mass situations that we were never able to observe until recently. So until now, gravitational waves were no more than a theory. And the way that we observed it was we got really lucky and we observed two black holes colliding. Now, in this first diagram, we see a red dot representing one black hole and a blue dot representing another black hole, and how over billions of years they slowly begin to collapse in towards each other. And you can see by the curved lines representing the curvature of space-time from the black holes. Now, as time goes on, billions and billions of years, the black holes slowly get closer and closer together, and the curved lines represent how more and more of space-time is being curved due to the black holes getting closer and closer together. The straight lines represent what space-time would normally look like, and the curved lines represent how the black holes orbiting and rotating towards each other affect the ripple of space-time. Now, what happens next is once the black holes begin to get closer and closer and closer, space-time becomes immensely more distorted, and it becomes so distorted at one point when the black holes get close enough that time and space are no longer relative to how we perceive them and just stretched beyond infinity, and it's pretty trippy stuff. And what's really cool about this is that while this whole process of the black holes orbiting each other and collapsing down over billions of years, this point in time, once they get close enough, happens at a faster rate than anything. It's infinitely faster than this and this. It takes no time for the black holes to actually collide. But in that very short amount of time, the black holes send out energy greater than the second greatest amount of energy output we've seen or observed or calculated since the Big Bang that created our universe. And as you can see here, space-time, represented by the grid, is just rippling all over. And the gravitational waves from these two black holes, millions of light years away from us, the ripples can be felt even where we are. And that's how we observed them, through these gravitational waves. And that was the first black hole collision we've ever noticed. The flower petal-shaped things are how the gravitational waves are sent out from the two black holes colliding. And these waves are only sent out in a very short amount of time, right before they collide and become an even bigger black hole. And this was originally just a theory because we had never seen black holes, and here's a good view of the whole process. So we start here with the theory of space-time. And larger objects with more mass have bigger divots, and the ripple was the theory. The black holes slowly move closer and closer together over time, and the closer they get, the more that the space-time around them is distorted, and eventually space-time is distorted to a point where time and space are no longer like they're no longer what's a good way to put it? They're no longer um, humans can no longer conceptualize or understand time and space. It's just in no way, shape, or form anything that we can understand when space and time are um, stretched and distorted to this point. And then, right before they collide, the gravitational waves are sent out in a magnificent pattern and they collide into one massive black hole. Thank you very much. This is Gravitational Waves and how they are created.